Discover how modern dredging machines and methods keep rivers and canals navigable, efficiently removing sediment and shaping waterways. The dredging and sand removal for the new Suez Canal represented an extraordinary engineering challenge due to the project's massive scale and, above all, its unprecedentedly tight deadline. Completing such an ambitious undertaking in less than 12 months had never been achieved before. The Suez Canal, the world's shortest shipping route between Europe and Asia, required expansion to increase transit capacity and stimulate industrial activity in the region. Therefore, a new parallel canal was constructed, designed with a depth of 24 meters, a width of 240 meters, and a total length equal to 1/3 of the existing waterway. To execute this demanding task, Yandi Nul Group deployed 7 powerful cutter suction dredgers, JFJ de Nul, Hondius, Caerius, Fernão de Magalhães, Ibn Battuta, Leonardo da Vinci, and Zhong He. Together, these vessels delivered an impressive total installed diesel power of 134,720 kilowatts. Their contribution formed the majority of the dredging effort, supported by the company's significant investments over the past decade, which resulted in the world's largest and most capable cutter fleet. As the canal's soil consisted mainly of compacted sand with intermittent layers of stiff clay, cutter suction dredgers proved to be the ideal machines for efficiently breaking, extracting, and pumping the material away to create the new navigation channel. Boscalis cutter suction dredgers are powerful vessels designed for dredging rock, clay, silt, and sand. They can be either self-propelled or stationary dismountable units, each equipped with a rotating cutter head that loosens the seabed. During operation, the dredger is firmly positioned using spuds and anchor winches. By pulling the side wires, the cutter head swings sideways around the main spud, allowing controlled cutting. The vessel advances through the spud carriage system as dredging continues. The cut material, mixed with water, is sucked into the suction mouth and pumped through long discharge pipelines or barges to designated reclamation or construction areas. The IHC backhoe dredger Alberto Alaman Zubieta is a powerful and highly specialized dredging vessel designed for excavating hard underwater materials with precision. Built by Royal IHC, this dredger features a robust hydraulic backhoe crane, mounted on a stable pontoon platform, allowing it to operate effectively even in challenging marine environments. At the heart of the system is a heavy-duty bucket capable of breaking and removing tough materials such as rock, boulders, old revetments, and underwater concrete structures. Alberto Alaman Zubieta demonstrates its exceptional digging force as it excavates dense layers beneath the waterline, using its long-reach boom and stick to deliver controlled, powerful strokes. The pontoon can be stabilized using spud legs, enabling the vessel to maintain precise positioning during critical operations. This ensures efficient material removal with minimal disturbance to surrounding areas. Backhoe dredgers like this one are essential for port deepening, channel widening, and infrastructure construction, where conventional suction dredgers are ineffective. Royal IHC's engineering provides high reliability, advanced hydraulic systems, and optimized cycle times, making the Alberto Alaman Zubieta a key asset for heavy-duty dredging projects around the world. Royal IHC is a global leader in the design and manufacture of integrated and highly efficient dredging vessels and equipment. The company supports a wide range of operations, including land reclamation, coastal protection, offshore trenching, port construction, and the extraction of sand and gravel. More than half of the world's dredging contractors depend on Royal IHC's advanced solutions, from trailing suction hopper dredgers and cutter suction dredgers to auxiliary vessels and specialized equipment. This strong trust demonstrates the company's ability to deliver excellent returns on investment while reducing the environmental impact of dredging activities. With innovative engineering and reliable life cycle support, Royal IHC continues to enhance the efficiency, safety, and sustainability of port maintenance and environmental dredging projects worldwide. MTCC operates a modern dredging fleet capable of handling major reclamation works across the Maldives. Since 2007, the company has deployed powerful IHC 1800 and 1600 cutter dredgers with 50-meter dredging depth, along with the three 700 cubic meters hopper dredger Maha Jirafu, ensuring efficient, self-reliant, nationwide dredging capacity. The dredging of the new Suez Canal was an unprecedented achievement completed within an extremely tight 12-month deadline. Designed to expand transit capacity between Europe and Asia, the new channel features a depth of 24 meters, a width of 240 meters, and runs one-third the length of the existing canal. Jan de Nul Group played a leading role, deploying 7 powerful cutter suction dredgers with a combined 134 720 kilowatts of diesel power. Their fleet, the largest globally, was ideally suited for removing compacted sand and layers of rigid clay. The step-by-step process of disassembling and assembling the IHC cutting head underlines Royal IHC's pioneering role in technological innovation. The cutting head is screwed onto the cutting shaft, so disassembly begins by removing it. First, the operator loosens the 3-part clamping ring located between the cutting shaft and the shaft neck. If a cutting ring is installed, the blocks must be cut with a torch. The cutter is then securely suspended from the hoist, secured with a chain around the arm to prevent the cutting head from tipping over and damaging the threads. Next, the shaft is slowly moved counterclockwise until the cutter is removed. Once removed, the shaft is cleaned, lightly greased, and all O-rings and seals are checked. The 3-part ring is retightened or tack welded if a cutting ring is installed. To reassemble, the cutter is positioned so that the shaft and threads are aligned, checked by moving it slowly counterclockwise. Once aligned, the operator moves clockwise until the cutter head engages the cutting ring. Finally, the firmness is confirmed by lowering the cutter to the seabed or rotating it through the side lifting eye. The 2014 maintenance campaign saw the hopper dredger Prins der Nederlanden sustain Maasvlakte 2, where Boskalis partner in the Puma Consortium continues 25-year upkeep of the Netherlands' largest hydraulic expansion. Trailing suction hopper dredgers are powerful ocean-going vessels designed to collect and transport sand and silt over long distances. Operated by Boskalis, these ships are essential for port construction, waterway maintenance, land reclamation, and coastal defense. Each dredger is equipped with 1 or 2 suction pipes ending in drag heads. Upon reaching the dredging site, the vessel slows down and lowers the pipes to the seabed. The drag head then moves steadily across the bottom, vacuuming a sand-water mixture that is pumped into the hopper. Dredging continues until maximum hopper capacity is reached. Depending on project needs, the vessel can discharge its load in several ways: rainbowing sand through a bow nozzle, pumping it ashore via floating or submerged pipelines, or releasing it accurately through bottom doors. This versatile system allows efficient and precise material placement for a wide range of marine works. In October 2013, a unique dredging operation took place at Keelung Harbor, Taiwan. Unlike conventional dredgers, this vessel relied on its excavators as paddles to maneuver through the water. The dredger was essentially a floating platform equipped with 2 large hydraulic excavators mounted on its deck. These excavators, typically used for digging and lifting sediment, were ingeniously repurposed to propel and steer the vessel. The operation demonstrated an innovative approach to maneuvering a heavy dredging vessel in confined harbor spaces where traditional propulsion systems were limited or unavailable. The excavators, buckets, acted as makeshift oars, pushing against the water to move the platform forward or backward. By coordinating the movements of both excavators, the operators could control the vessel's direction with surprising precision. During the dredging process, the vessel collected sediment from the harbor bottom while simultaneously repositioning itself using the excavator paddles. This dual functionality allowed for continuous operation without reliance on external tugs or engines, making it particularly suitable for shallow or congested areas. The technique highlighted the versatility of hydraulic excavators and the creativity of harbor engineers in adapting available equipment for challenging tasks. This unusual method not only showcases the adaptability of construction machinery, but also underscores the ingenuity required for efficient harbor maintenance. It remains a fascinating example of practical problem-solving in maritime engineering. On October 15, 2013, at Keelung Port, the dredger was shown equipped with 2 deck-mounted excavators. These excavators are used to scoop and remove sediment from the harbor floor, effectively removing mud, sand, and debris. The dredger itself is a flat-deck vessel, allowing it to carry heavy machinery and operate in shallow waters. One excavator is placed at the bow of the vessel for forward dredging, while the second excavator is placed amidships or aft to increase efficiency and coverage. The combined operation of these 2 excavators allows for continuous dredging, improving the port's navigability and maintaining safe water depths for ships. This setup demonstrates a flexible and relatively simple dredging method, Relying on a conventional excavator rather than a specialized cutter or suction system, the Komatsu PC800LC crawler excavator is at work in Germany, loading soil and rock onto trucks. Renowned worldwide for quarry and mining operations, it combines powerful digging force with exceptional drawbar pull and steering. Designed with operator safety and comfort in mind, its Komatsu-developed engine, hydraulic, and electrical systems deliver high performance while keeping fuel consumption low. This robust and efficient excavator ensures productivity and reliability, making it a valuable asset for heavy-duty earth-moving and mining projects. The Veshamate offshore wind farm installation showcases an impressive engineering feat in the North Sea. The project comprises 67 XXL monopile foundations designed for 6 megawatts turbines, capable of producing enough energy to power 400,000 homes across Germany. These massive monopiles were designed and fabricated in Rostock, Germany, and then transported via barges along the Kiel Canal to the feeder port in Eemshaven, Netherlands, ready for offshore installation. The installation vessel Scylla was mobilized with a bespoke 650-ton, double-level pile gripper frame, enabling operations in higher sea states. This vessel was used to upend the world's largest monopiles, measuring up to 85 meters in length, 7.8 meters in diameter, and weighing as much as 300 tons. Each monopile was carefully driven to its target depth, with noise mitigation measures in place, including a hydro-sound damper and a double big bubble curtain, ensuring environmental protection during the piling process. Following monopile installation, survey tools were employed to conduct top-flange surveys with laser precision, confirming exact positioning. Transition pieces and subsea anode cages were transported from Aalborg, Denmark, to Eemshaven for subsequent deployment. Before installation, marine growth was removed and subsea anode cages were carefully installed to provide long-term corrosion protection. Bolting and grouting finalized the connections, ensuring structural stability. Scour protection around the monopiles was installed by the fall pipe vessel Rockpiper, safeguarding the seabed and the foundations. The coordinated efforts of design, fabrication, transport, and installation reflect meticulous planning and advanced engineering, culminating in a highly efficient offshore wind farm. The Veshamate project stands as a benchmark for offshore wind energy, demonstrating both technological innovation and environmental consideration in renewable energy deployment. The Ellicott 370 Dragon dredge is a versatile and widely used cutter suction dredge, ideal for river dredging and sediment removal. Its combination of portability, durability, and simple operation makes it a popular choice for maintaining navigation channels, restoring wetlands, and managing flood control. Designed to be easily transported and deployed, the 370 Dragon can be operated by a single person, making it highly efficient for a variety of river-related projects. One of the key features of the dredge is its rugged construction. Components such as the chrome carbide dredge pump and the alloy steel cutter shaft ensure long-term reliability and consistent performance, even under demanding conditions. The dredge's customizable configurations allow operators to adapt to specific project requirements, including different digging depths, enhancing its versatility for multiple applications. In practical use, the Ellicott 370 Dragon is commonly employed to deepen rivers, improving navigability for vessels. It efficiently removes accumulated sediment, which can obstruct water flow and increase the risk of flooding. Beyond navigation, it supports infrastructure maintenance, ensuring canals and waterways remain clear, and contributes to flood control by restoring natural flow patterns. Additionally, the dredge plays a crucial role in environmental restoration, assisting projects that rehabilitate wetlands and shorelines. The trailing suction hopper dredgers Utrecht and Ham 318 played a pivotal role in the KNPC Al-Zour project in Kuwait by efficiently connecting their bow hopper systems to floating pipelines. Both vessels were equipped with a standard 100 mm diameter bow connection unit, specifically designed to enable the discharge of dredged material over the bow directly into floating pipelines. This setup allowed the dredged sand and other materials to be transported to reclamation sites on shore over long distances. The bow connection functions as a crucial interface for the pumping system, facilitating the controlled transfer of sediment from the vessel to the pipeline. On this project, material was pumped up to 12 kilometers to expand land for the refinery. The self-emptying suction system of the vessels ensured continuous and efficient dredging operations, minimizing downtime. To maintain sufficient flow and pressure over such distances, the dredgers utilized powerful booster pumps. The system combined the onboard 15,000 kilowatts boosters of the jumbo TSHDs with an additional 5,000 kilowatts land-based booster, ensuring consistent transport of dredged material. This integration of bow connections, suction systems, and booster technology exemplifies the advanced dredging capabilities deployed during the Al-Zour land reclamation project. The Suez Canal, one of Egypt's most iconic engineering achievements, faced a major challenge. A 35-kilometer stretch allowed only one-way traffic, causing delays of up to 11 hours for passing ships. To modernize this vital route, a new parallel waterway was constructed, enabling two-way navigation. Originally planned for 3 years, the project was completed in just 10 months, moving over 2 million cubic meters of sand, equivalent to 80 Great Pyramids. With 28 dredgers, 800 personnel, and around-the-clock operations, the Second Suez Canal stands as a 21st century symbol of human ingenuity and engineering excellence. The Watermaster is a highly versatile amphibious multi-purpose dredger designed for all shallow water operations, from dry ground up to 6 meters depth. Its amphibious capability allows it to be transported as a complete unit and ready to work immediately, without the need for time-consuming setup. Self-launching, it can enter the water independently without crane assistance, and its self-propelled design ensures it can move and operate without wire cables or supporting vessels. Equipped with a submersible Watermaster cutter pump, the dredger can handle a dredging capacity of 500 to 900 cubic meters per hour. Its large work area minimizes repositioning, improving productivity across a wide range of applications. The Watermaster is multi-purpose, performing dredging, raking, piling, and more, effectively replacing several single-purpose machines. It can discharge dredged material up to 1.5 kilometers away, making it ideal for maintenance and deepening of shallow waterways. In environmental applications, the Watermaster prevents floods by removing silt, trash, and invasive vegetation from rivers, lakes, and canals. In construction, it supports water infrastructure projects such as marinas, piers, and floodwalls. Industrially, it maintains ponds and recovers valuable materials. Its wide selection of work attachments ensures adaptability to multiple tasks while reducing costs, environmental impact, and the need for multiple machines. The Watermaster handles work conventionally, requiring several separate machines, including dredging, excavating, raking, and pile driving. Mobilization is simple. It can be transported as a unit, unloaded from a trailer, and independently enter the water. Its own propulsion system, 4 stabilizers, and a flexible excavator arm allow quick anchoring and operation. No tugboats or assisting machinery are needed. Proven in quality, performance, and service, the Watermaster ensures cleaner, safer, and better functioning waters. By combining dredging, vegetation removal, and infrastructure support in one amphibious machine, it saves time, resources, and environmental impact while enhancing the functionality and safety of urban and natural waterways. Dredging is a crucial process in maintaining navigable waterways, reclaiming land, and supporting various construction projects. Over the years, a wide range of dredging methods has been developed, each designed to meet specific site conditions and project requirements. The clamshell dredger is a widely used mechanical dredging machine that operates with a bucket shaped like a clamshell. It is suspended from a crane or derrick and lowered to the seabed or riverbed to scoop up sediments. This bucket is capable of handling a wide range of materials, including sand, silt, and small rocks. Clamshell dredgers are highly versatile, suitable for precise excavation in confined areas such as harbors, near port facilities, or around bridge piers. The machine allows controlled material removal, making it ideal for harbor maintenance, deepening channels, and dredging around sensitive structures. The backhoe dredger is another mechanical dredging machine designed with a hydraulic excavator mounted on a barge. Functioning similarly to a land-based excavator, it is adapted to work in water. Its hydraulic system provides precise control, enabling careful excavation without disturbing surrounding areas. Backhoe dredgers are effective for a variety of sediment types and are frequently used in canal deepening, river maintenance, and port construction projects. Their ability to operate in shallow and confined waters gives them an advantage where precision is crucial. The mechanical dredge bucket ladder is a classic type of dredger that utilizes a continuous chain of buckets mounted on a ladder-like structure. The buckets rotate around the ladder, scooping material from the riverbed or seabed and delivering it to a discharge system. One prominent example is the Bayer-Eimerkettenbagger, a high-capacity bucket ladder dredger capable of excavating large volumes of sand, clay, or gravel. These machines are highly efficient for large-scale projects, including building canals, maintaining deep navigational channels, and extracting aggregates for construction. The continuous bucket chain ensures steady excavation and reliable sediment handling. The mechanical dragline dredger operates with a large bucket suspended from a boom that can swing over the water. The bucket is dragged along the seabed or riverbed to collect sediments, then lifted and emptied onto a discharge platform. Dragline dredgers are particularly effective in soft, cohesive soils, such as clay or silt, and are frequently used in river deepening, lake maintenance, and land reclamation projects. Their long reach and flexibility allow material to be excavated at a distance from the dredger barge, which is useful for sensitive or hard-to-access sites. The hydraulic cutter-head dredger is a prominent type of hydraulic dredging equipment. It features a rotating cutting wheel at the suction inlet that loosens compacted or hard sediments. Once loosened, the material is suctioned through a pipe as a slurry and transported to a disposal or reclamation site. Cutter suction dredgers are suitable for a variety of materials, including sand, clay, and gravel, and are widely employed in river training works, port deepening, and land reclamation projects. Their ability to handle both soft and dense materials makes them versatile and efficient for large-scale hydraulic dredging. The plain suction dredger is a simpler hydraulic dredging machine that relies solely on suction to remove sediments. Unlike cutter suction dredgers, it does not use a cutting head, making it ideal for loose, unconsolidated materials such as sand and silt. Plain suction dredgers are often deployed for shallow water projects, beach nourishment, maintenance of channels, and sediment removal from lakes or reservoirs. Their relatively simple design allows for quick setup and operation in locations where sediment is soft and easily transportable. Finally, hydrodynamic dredging machines represent a modern and environmentally sensitive dredging method. These systems use controlled water jets or circulation flows to suspend and move sediments without direct mechanical contact. The dredged material is transported through water currents to collection points or disposal areas. Hydrodynamic dredging is particularly suitable for fine-grained sediments and confined waterways. It minimizes disruption to the surrounding environment while providing precise sediment control. These various dredging machines, whether mechanical like clamshell, backhoe, bucket ladder, and dragline dredgers, or hydraulic such as cutter head, plain suction, and hydrodynamic systems, each bring specific advantages. They are selected based on sediment type, water depth, project scale, and environmental considerations.